Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the today's session, I will discuss the question which was asked in the GATE 2025 engineering science paper from the solid mechanics. So coming to the question number 15, a vertical column which is fixed at one end is subjected to a compressive axial load at the free end. The flexural rigidity value which is given and the cross-sectional area is given as 7.85 into 10 to the power of minus 3 meter square. And length of column is 2 meters. The yield strength of material which is given as 145 megapascal. If column can fail by either in buckling or by Tresca criteria, the maximum load that the structure can safely sustain is, you have to calculate how much load it can bear without undergoing any failure. So for that, you have to check with the both the criteria. One is the Euler-Buckling criteria, and the second one is the Tresca criteria. Okay, so let me first write down what is the data given in this particular question. So the flexural rigidity value, that is nothing but EI, which is given as 9.82 into 10 to the power of 5 Newton meter square. The cross-sectional area value is 7.85 into 10 to the power of minus 3 meter square. And length of column is given as 2 meter. Okay. So the yield strength value is given as 145 megapascal. Now, what is the condition given? The condition is one end of the column is fixed and another end is free. Let us suppose this is the column. Now, whose one end is fixed and another end is free at this particular end. Let us suppose one load which is acting as a, so that means the column is subjected to axial compressive load. So you have to calculate how much the maximum load it can bear without undergoing any failure. Okay, so you have to check with both the criteria. So let us suppose the first criteria is by using Euler buckling criteria, or Euler buckling relation. What is the Euler load? Pi square EI effective length square. Now, if one end is fixed, another end is free, so the effective length of the column, is nothing but 2 times of length of the column, which is nothing but 4 meter or 4000 millimeter. 4000 millimeter. Okay, so you just plug all these value, EI value and effective length of column, then you will get the answer for this Euler load. So pi square, what is the EI value? So let me check. 9.82 into 10 to the power of 5 Newton meter square. So if I will convert into millimeter square. So this will become 10 to the power of 6. And this is nothing but 4000 square. Once you will solve, then you will get the load value 605.746 kilonewton. Okay. Now, by using the by using Tresca criteria, the maximum value of shear stress is equal to the yield strength divided by 2. And how you will calculate the maximum value of shear stress? The maximum value of shear stress is nothing but sigma 1 by 2, because sigma 2 is 0, because only one axial load which is acting. So here I can write sigma value is, sigma 1 is nothing but P by A and sigma 2 is 0. So this will become P by A, which is equal to sigma Y. So from here you can calculate the value of P. Sigma Y is given as 145 and the area which is given as 7.85 into 10 to the power of minus 3, which is in meter square. So will become millimeter square if you multiply with 10 to the power of 6. Once you will solve, then you will get the value of 1138.2 0.25. Okay. So you have to calculate how much maximum load it can bear. So suppose if you are taking this value, then it will fail due to the buckling. So that means you have to take the minimum value of load out of these two. The load carrying capacity is nothing but the minimum value of these two. So P and PE, whatever. So the minimum value of P and PE is 605.746 kilonewton. So that will be the answer for this question. Okay. So this much amount of load that column can sustain without undergoing any failure. Now let's move to the next question. Question number 16. In the given spring mass system, at time t is equal to 0, the mass is displaced by P unit and the velocity of mass is 0. The displacement of mass xt is measured from the equilibrium position. Which one of the following function represent xt? That means you have to calculate what will be the displacement of mass with respect to the time t. And for that, they have given you the condition at time t is equal to 0. The displacement of that block is p unit and the velocity is 0. Okay, so I will utilize this condition for finding the generalized equation of the displacement. Okay, now at time t is equal to 0, what is given? X is equal to p and the velocity value will be 0. Velocity value will be 0. Okay, so the natural frequency you know that of a spring mass system is k by m. Now the displacement equation of spring mass system is given as x is equal to a sine omega nt plus b cos omega nt, where a and b are the constant that you will find out by using the given condition. Now, the displacement at time t is equal to a sine omega nt plus b cos omega nt. So, if you differentiate this value, so let me first put the value of omega n. So, x is equal to a sine root of k by m into t, b cos root of k by m into t. Now, if you differentiate, then it will become x dot a root of k by m. Sign differentiation is cos plus b. Cos differentiation is minus sign. So that means this will become minus root of k by m sine root of k by m into t. Okay. Now, if you put the condition at time t is equal to 0, the velocity value is 0. So the velocity value is 0 at time t is equal to 0. The velocity value is 0. So time t is equal to 0 means cos 0 is 1 and sine 0 is 0. So this will be cancelled out and that means it will become 0. So what you will get? A root of k by m cos 0 is 1. That means the value of a which you are getting as a 0. Okay. So the first constant which you got as a 0. Now the second constant b value you will get once you will put time t is equal to 0, x is equal to p. Now at time t is equal to 0, x is equal to p. So what is the equation? X is equal to b cos root of k by m into t. Why? Because a value is 0. So if you put the a value is 0, now what you will get the displacement equation? X is equal to b cos of root k by m into t. So x is equal to p when time t is equal to 0. That means cos 0 is 1. So p value which you are getting as a p. So can I write the generalized equation? Now, what is the equation become? P cos of root k by m into t. Okay. This is the displacement of that particular, or we can say that this is the displacement of the mass m. X is equal to P cos of root K by M into T. If you check the options, the option A is correctly matching. So choice A is the correct answer. Choice A is the answer for this question. Two cars P and Q traveling on a straight path and are 60 meter apart as shown in the figure. Both cars are moving at a constant velocity. Okay. At this instant, the driver in car P applies the brake and the collision occur with car Q after 30 seconds. Okay. So what is happening? So they are moving with these velocity which is given in the figure. Now, once this car P apply the brake, what will happen? After 30 seconds, it will collide with the car Q. So assuming uniform deceleration due to the braking, so which one of the following is correct velocity of car P just before the collision? You have to calculate. Okay, so the four options are given. So you have to calculate just before the collision, what will be the velocity of car P? Okay, so let's try to understand this problem. So what is the data given? The velocity of P is 36 km per hour and the velocity of Q is nothing but 18 km per hour. So can I convert this kilometer per hour into meter per second? Yes, just multiply with 5 by 18. So 36 into 5 by 18, it will become 10 meter per second. And this value will become 18 into 5 by 18. This will become 5 meter per second. So the velocity of P and the velocity of Q you have calculated 10 meter per second and 5 meter per second. Okay. Now, if you see this particular diagram, so the distance between P and the car Q is nothing but 60 meter at this particular condition. So can I write the displacement XP minus XQ, which is nothing but 60 meter, 60 meter. So what is the displacement? Which is nothing but UT plus half of UT plus half of AT square for the P. Similarly, UT plus half of AT square for Q, which is nothing but 60. Now, what is the initial velocity? This is 10. So I'm just talking about at the time t is equal to 30 seconds. So t value is 30 plus half of a into 30 square minus this value is 5 into what is the value of t? T is 30. Okay, just before the collision means it is both are moving with the constant velocity. That means the acceleration value will be 0. So here in the case of q, the acceleration value is 0. So which is nothing but equal to 60. From here you will get the value of acceleration. So this is nothing but 300 plus half of a into 30 square minus 150. This is 60. So from here if you solve, you will get the acceleration value. Acceleration value. So this value is 150 minus 60. This is minus 90. Okay. Now the acceleration value you will get as minus 0.2 meter per second square. Now you can see here the acceleration value which is coming out to be negative, which is nothing but the deceleration. Okay, so now you can easily calculate the velocity of P. So now the velocity of P just before the collision is UP plus AT. What is the velocity of P in the initial condition? This is 10 and the acceleration is minus 0.2 and the time is 30. So once you will solve, then you will get 4 meter per second. 4 meter per second. Now you can check the options. Yes. Option A is 5, B is 1, C is 16 and D is 4. That means the correct answer for this question is choice D. Correct answer for this question is choice D. Okay. So thank you so much.